Okay, now in this exercise, I'm going to talk about example 25 in a minute, but again, I'm going to give you a little heads up before I proceed with that. Now we're working the reverse. I'm giving you the derivative function. What does the original function look like? Now, you all know that we just talked about this, that obviously this is going to be x squared. But let me say something to you. What if I have this function here? Okay, let's say it crosses over at 5. So therefore, the original function is x squared plus 5. If I take the derivative of that, I'll get this because the 5 drops. The derivative of 5 is 0, right? But it still applies. It is still correct because the slope at 0 is 0. It's a plateau. Here it's at 2, here's at 4, here's at 8, and so on. It's still applicable, even if it was down here, right? What if the function was f of x equals x squared minus 4 or 7? Okay, and this is minus 7, okay? It's still going to be a derivative of this one, okay? So, because again, it plateaus here, it's positive, it gets higher and higher, and then here it's negative, it gets more and more steep, more and more negative, all right? So basically what I'm trying to tell you is, if we're going backwards, we don't know if it's this, or even just this. We don't know. There's no way of knowing that. Why f of x equals just plain x squared, right? So basically, in the next chapter, when we talk about integration, we are going to learn how to go backwards, all right? The thing is, though, when we do go backwards, then basically we have to write down this way. This is the proper way to do it. It's f of x equals x squared plus c, okay? And because c will be, this is constant. Why? Because we don't know where it is. It could be up here, could be up here, could be up here, could be up here. We don't know where it is. We know what the shape looks like, but we don't know where it is. So when it comes to trying to figure out the original, again, we don't know where it is when we try to sketch it out. We can shift it up and down as much as we want, but that doesn't matter. We're just trying to figure out what it kind of looks like. Okay? So what we need to do now, we don't take the plateaus and map it down to 0 because, again, we're going back to what we did here. We're going backwards now, all right? So we notice that the slope is 0. Again, this is the derivative function. It's a slope function. We know the slope is 0 here, 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 and here. Okay, now I'm going to grab a pencil, which is here. Okay, I'm going to grab a pencil, and then this is what I'm going to do. I'm going to draw dashes like this. Very light dashes. Wherever the plateau is 0. Like that. Basically, it's telling me it's going to cross over here, like wherever a graph I draw, whatever I draw, it has to plateau along here. We don't know where, but it has to plateau along here, okay? So, I can just pick one. It doesn't matter. You don't have to do it here. You could do it up here. It doesn't really matter. So, let's say we do it, I don't know. How about here? I'm just picking a spot. Here. Okay, it plateaus. So what I'm drawing now is the actual original function. Okay, so it plateaus here. The slope here is negative, which means what? I have to draw a negative slope from here. So let me repeat myself again. To the left, this slope function is negative. So I have to draw a negative slope from the original function. So what's the negative look like? It actually looks like this. Okay, because if I draw this, it's a negative slope. See, this is why it might take a while for you to get your head around it. Okay, it looks like it's going up, but no, it's a negative slope because the slope function is negative below the x-axis. Okay? So now, between here and here, the slope is positive. Okay, the slope is positive. So it means it has to go up like, it has to be like this. Okay, the slope is positive. So I'm going to draw it over here, and I know over here it's going to be back to negative slope. It's going to be back to a plateau. I'll draw some more of this. So I'm just going to, put a little dot over here because I know between here and here it's a positive slope as shown here. So I will draw a line like this, like that. Okay. Now I have another negative slope here, but what is the slope? Is it positive or negative? Well, it's below the x-axis, so it is negative. So I'm going to draw, I don't know, maybe something like this. Again, we don't know, and I'm just sketching. So it goes down like this. Okay, it has to plateau here because the slope here is 0. So it's negative here, right? Just because it dipped below 0. And finally, we have another plateau over here, and is the slope positive? Yes, it's above the x-axis, so the slope is positive. So it needs to go up. The slope has to be positive like this, so it needs to go up, so I'll make it go up to here. I'm just picking something at random, it doesn't matter, but at least you get the idea what it looks like this, okay? And finally, the slope is negative to the right of this point right here. The slope is negative, so it has to go down because the slope is negative. Okay? And what do you notice? Well, the turning points of this derivative function is 1, 2, 3, 3. And how many turning points do we have here? This is f of x. And the turning points is 1, 2, 3, 4. Okay? Which makes sense, right? Because now you expect it to go higher. Again, I don't know where it is on the graph. This whole blue thing I just drew could be up here, could be down here, could be down here. We don't know. All right? All right, thank you.